Okay, so this is part 2 to the other video. And so we did one example in the other video, and so this will be example 2. This time we do have an h and a k for our center. And so remember that the sign changes here, and so my center would be 5 and -2. And it may be a good idea for you to go ahead and graph this as I work through this. So I'm going to graph 5, -2. So 5, -2. So 5, -2 is going to be my center. And then from there, my vertices are going to be, this is going to be my bigger number. And so the square root of 9 is 3, and the square root of 4 is 2. And so my vertices are going to go up and down 3 from the center. And so honestly, I like just doing this from the graph, and then I don't have to think math-wise. I can just think, what am I doing on my graph? So I'm going up 3 spaces, and so that's going to be at 5, 1, and I'm going down 3 spaces. And so I'm going down to 5, -5. And so this is a vertex, and this is another vertex, and that's going to be my center. And so my 2 points on my vertices are going to be 5 and 1, so -2 plus 3, and then -2 minus 3 is going to be -5. So if you like thinking about it with algebra and adding and subtracting, do it that way. If you like thinking about it from the graph perspective, do it that way. The co-vertices are going to go the other direction, and so these are going to be my x values, and so I'm starting at 5, and I'm going to add 2, and I'm going to subtract 2. So this is going to be 3, -2, so 5 minus 2, and 5 plus 2, so 7, -2. And we can graph those points as well. So I'm going 2 spaces to the left, that's 3, -2, and 7, -2. And so this is a co-vertex and a co-vertex. And then I can connect oh goodness, this is bad. I can connect all my points as beautifully as possible to get your ellipse. And so that is what our shape is going to look like. And so on the last problem, we had a horizontal ellipse because our shape is longer on the horizontal axis. This time, the longer axis is my vertical axis, and so that's going to be a vertical ellipse. So now my foci, I have c is equal, remember it's the bigger denominator minus the smaller denominator square rooted. So 9 minus 4, and that gives me the square root of 5, and the square root of 5 is 2.2, approximately 2.2. And so then my eccentricity is the c. We said in the equation that it's c over a, but it's really c over the major number. So 2.2 divided by the bigger denominator's square root. And so this would be 2.2 divided by 3, and that gives us approximately 0.75. And so the eccentricity of this one is about the same as the eccentricity was on the other problem. And so then my major axis is twice as long if I'm going 3 up and 3 down. My major axis is all the way across, and so that one's going to be 6. And my minor axis is 1, 2, 3, 4, so 2 and 2 all the way across. So this one's going to be 6, and this one's going to be 4. And let's also graph our focus points. And so here, if my distance from the center to my focus point is 2.2, I'm going to go up this time because I'm going on the major axis. So I'm going up 2.2, I'm going up 2.2, and I'm going down 2.2. And so this is one focus point, and this is the other focus point. And that's our information all about this problem here. We can also see some information about numbers that aren't perfect squares. Like, they do not have to be perfect squares, and that's okay. But our center is going to be the same, so this would be -2, -4. The bigger number is 12, and I want to know what the square root of 12 is and the square root of 10 is. So the square root of 12 is 3.5, 3.46, however you want to round that. And then the square root of 10 is 3.16. So these numbers are much closer together than the other ones were. And so my vertices are going to go up and down from -4. And so like I said, if it's easier for you to do the graph, and so from here I'm going up 3.5, and so from here I'm going up 1, 2, 3.5, and down 1, 2, 3.5. And so here's a vertex, here's another vertex, and the other distance I'm going to go is 3.16. So 1, 2, 3, and just a little bit. 1, 2, 3, and just a little bit extra. And so that's a co-vertex, and that's a co-vertex. And so just like before, I can poorly draw an ellipse here for you. So hopefully you see that this one is a little more round, closer to being a circle. And so when we look at our eccentricity, we can talk about that. So our vertices are going to be at -2, -0.5, -2, -0.5, and this one is going to be at -5, 6, 7.5. And so we can add those to our vertices, -2, -0.5, and -2, -7.5. So our co-vertices are at -5.1, -4, and 1.1, -4.1, or 5.16, 5.2, something like that. So we're just adding and subtracting this one. So 5.16 and -4. So it's changing the x value on this one, and 1.16, -4. So then our foci, the focal length is C equals the bigger number, and remember it's the squared number, so 12 minus 10 square rooted, and so this is going to be the square root of 2, and that is 1.4. And so we're going to move up and down 1.4. So up 1.4 and down 1.4. So up 1.4, down 1.4, and so that's my focus point. And that's my focus point. And so then my eccentricity is this number over the larger number, so 1.4 over 3.5. And that gives me 0.4. And so this eccentricity is a smaller number than the previous eccentricities. And so what that means here is that this is more stretched out and it's further from looking like a circle, and this one is a little more round, even though my drawing is bad. It's a little closer to looking like a circle in this one. So then my major axis is 2 times this, and so this would be approximately 7, and then it'd be 2 times this would be approximately 6.32. And so hopefully that helps your understanding whether it's whole numbers or it's decimals on our denominator numbers.